Okay, well, we can simplify radicals. What are some of the other operations that we can do with radicals? Well, some of the other operations are addition and subtraction. For example, we can add and subtract radical expressions if they have like radical terms. And in this case, for example, you see that the square root of 2x is a like factor for each of the two terms right here. And so we add or subtract these like terms by adding and subtracting their coefficients. This is really a lot like saying 5 plus 3 times the square root of 2x, right? And, well, 5 plus 3, what's that? That's 8. So it's 8 times the square root of 2x. So if you think about it as a distribution property problem, we can see this is 8 times 2 square root of 2x. That would be our simplified form. All right, how about some of these where it's not so obvious? Well, what we'll need to do is we'll need to actually go through and simplify each of these radicals. So let's take them on one at a time over here. What could we do if we had the square root of 12a cubed b? Well, we need some perfect square factors. We've already dealt with something like 12, right? 12 has a factor of 4, which is a perfect square, so it's 4 times 3. And a cubed, well, that's really the same thing as a squared times a, and we're still multiplying that by b. That has no perfect square factor. So if we divide that up, it's really like saying, well, the square root of 4 and the square root of a squared, right? Those are our perfect square factors, times the square root of 3ab left over. And so this is really like saying 2a times the cube root of 3, the square root of 3ab. All right, so in this first term, if you look at what we actually have right here, we actually have 2b times the quantity 2a, square root of 3ab. Okay, and we could simplify that a little bit more, right? Because 2b times 2a becomes 4ab. So we've got 4ab times the square root of 3ab. But then we have this second term over here, and we need to deal with that guy. So we're going to have a times something. But what? Well, let's do this one off to the side over here. If I had my square root of 192, a little bit more difficult, but I think we can figure this one out, a times b cubed, what could we find? Well, let's see, 192, let's think about that one. 192, maybe it's not as obvious right off the bat what we could do, but it is definitely divisible by 2. Well, 2 times what gives me 192? Well, let's see, 2 goes into 192. Let's see, that's 9 times, gives me 18. Subtract that off. 9, that's 1 and 2. 2 goes into 12 6 times. So 96. Wait a minute, and that's still divisible. Right? 96, what do we divide by there? Well, 2 goes into 96, happens to be 443. So we have 43? No, wait a minute. Something's not right there. 2 times 43 isn't 96. Come on, Professor Peoples, learn your division. Let's see. I'll just do this off to the side here. If we continue on doing our division, let's see. 2, we got 96 here. 2 goes into 96 how many times, folks? Let's see. 4 times. 4 times 2 is 8. Subtract 1. Bring down the 6, 48. Ooh, we're still divisible. Right, we can keep on going right here. Let's see, if we work out a little factor tree, let's see, what have we got so far? We've got 192 is the same thing as 2 times 96, which is, get my pen working here. Come on, pen. 96, which is the same thing as 2 times 48. This one's a little bit more easily seen, right? This is 2 times, that's right, 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Wait a minute. So we've got 2 multiplied by itself 1, 2, 3, 4, 5, 6 times. This is the same thing as 2 to the 6th times 3 times a times b squared times b. Now this is a perfect square factor, right? 2 to the 6th, what is 2 to the 6th? 2 to the 6th is 64. Right, so this is like saying 64, which we know the square root of, times 3a times b squared times b. So if we take out our perfect square factors, what do we have? 8 and b times the square root of 3ab. Aha, we've got it. So we've actually got a times 8b times the square root of 3ab. So if we put that together, we've got minus 8ab times the square root of 3ab. And lo and behold, we do have like binomial, like radicals right here that we could subtract. 4ab times square root of 3ab minus 8ab square root of 3ab should give us, as a result, negative 4ab times the square root of 3ab. All right, so by reducing, we can actually add these guys together, and that's what you're going to find. We will have to reduce some of these radicals completely. All right, more in the next video.